Have you ever wondered how we can learn about the Earth's surface without actually being there? The answer lies in a field of study called remote sensing. In this video, we'll be exploring the basics of remote sensing and how it works. Let's start with a simple example. When we take a picture of something using a camera, we are essentially capturing light that is reflected off the object and into the camera lens. Remote sensing works in a similar way, but instead of using a camera, we use sensors that can detect different types of energy. Remote sensing involves 7 key elements that work together to gather information about the Earth's surface. The first element is the energy source or illumination. This is what provides the energy that will interact with the target. The energy then passes through the atmosphere, where it may interact with the gases and particles in the air. Next, the energy interacts with the target, depending on its properties and the type of radiation. The energy that is scattered or emitted from the target is then recorded by a sensor that is not in contact with the target. The recorded energy is then transmitted and processed into an image that can be interpreted and analyzed to extract information about the target. This information can be used to better understand the target or solve a specific problem. Remote sensing can be used in many different fields, from studying the environment to mapping urban areas. It allows us to gather information about the Earth's surface without having to physically be there. Here are some examples that relate to the 7 elements of remote sensing. Energy source or illumination. An example of an energy source for remote sensing is the sun. The sun provides electromagnetic energy that is used by remote sensors to collect information about the Earth's surface. Radiation and the atmosphere. The atmosphere can affect how much radiation is absorbed or reflected by the Earth's surface. For example, clouds can block the sun's rays, making it more difficult to collect data about the Earth's surface using remote sensing techniques. Interaction with the target. Remote sensing can be used to study a wide range of targets, such as forests, oceans, and urban areas. For example, remote sensing can be used to study how vegetation changes over time, or how land use patterns in urban areas are evolving. Recording of energy by the sensor. Remote sensors record the energy that is emitted or reflected by the target. For example, a satellite sensor might record the amount of reflected sunlight from a particular area of the Earth's surface, which can be used to create an image. Transmission, reception, and processing. After the energy has been recorded by the sensor, it needs to be transmitted and processed into usable data. For example, a satellite might transmit data back to Earth, where it is processed into images or other types of data. Interpretation and analysis. Once the data has been processed, it needs to be analyzed and interpreted to extract useful information. For example, scientists might use satellite imagery to study the effects of deforestation on biodiversity or to identify areas at risk of flooding. Application. The final step in the remote sensing process is to apply the information that has been collected and analyzed. For example, remote sensing data might be used to inform land management decisions, or to identify areas at risk of natural disasters like wildfires or hurricanes. Thanks for watching.